So I would like to quickly introduce myself because I've actually been working with HE for over 8 years now, although none of you have seen me at any of the laterality meetings. That's because I started on a completely different topic during my PhD for other historical unrelated reasons. But a couple of years ago, I think 2 or 3 years ago, he was able to lure me into the laterality research topic. And I've actually been working a bit behind the scenes together with the lab. You might have seen my name disappear a couple of times today, actually, on the Laterality Index Consensus Initiative, the study of Robin with right language dominant people, and also with the Citizen versus 2 study. But today I would like to present my first own kind of research line within this laterality topic. And I'm looking at laterality in people with dyslexia. This is actually just a very, very small piece of my giant project puzzle. I've been doing MRI with functional structural imaging in these people with dyslexia, but today it's just a very small piece of behavioral data. So the topic is the interhemispheric deficit theory in dyslexia, and I use a lexical decision task to look at this. So, as you all know, dyslexia is a developmental disorder that is characterized by difficulties with reading and spelling. And according to the interhemispheric deficit theory, this is caused by disruptions to the information transfer between the hemispheres across the corpus callosum. And this is actually in line with this theory. There has been some reports of people with dyslexia experiencing more problems on tasks that require interhemispheric transfer. And also some studies found that there are differences in the structural properties of the corpus callosum in people with dyslexia compared to controls, although those results are not always consistent. So a way of behaviorally probing this interhemispheric transfer is by using the visual Hall-field task. And during this task, a participant, just briefly gonna go over it, I'm guessing most of you know by now, but during this task, a participant is asked to respond to stimuli that are presented either to the left or the right visual field. And the idea is that information that is presented to the visual field is projected initially to the contralateral hemisphere, so that differences in reaction time and accuracy scores can actually be a reflection of the cost of transferring information to the hemisphere that is dominant for that specific task. So in the case of language, because I use the language task, there is a right visual field advantage. Actually, when I was making this talk, I thought it would make more sense to say that it's a left visual field disadvantage. Because if we look at this again, if you present a word in the left visual field, it gets projected to the right hemisphere, and it needs to cross over to the left language dominant hemisphere to get analyzed and processed further. So this extra step of crossing the hemispheres across the corpus callosum makes reaction times a little bit longer and accuracy scores a little bit lower, leading to this left visual field disadvantage, or as we often call it, this right visual field advantage. Another interesting observation is the fact that if you present two identical stimuli simultaneously to the left and right visual field, that you see that it results in even better performance than when you only present it to the right visual field. And this is referred to as the redundant bilateral advantage. And it's a result of cooperation between the hemispheres and the bad hemisphere still being able to help the good hemisphere to process it even better and faster. Okay, so we have the right visual field advantage, we have the redundant bilateral advantage, and we have the idea of a problem with interhemispheric transfer in people with dyslexia. So there are two hypotheses that you can make. The first one is that people with dyslexia will show a poor left visual field performance because the extra step of crossing the corpus callosum is a bit deficient in them. So this will actually increase their right visual field advantage because of lower scores on the left visual field. So the difference between the two will become bigger. Secondly, adults with dyslexia, they will not, or at least into a smaller extent, benefit from a bilateral presentation, which will then result in a decrease in this advantage of bilateral stimulation. Very interesting, but I didn't come up with this myself. Previous research studies in dyslexia have already looked at this. The first one I could find was by Henderson and colleagues, and indeed they found an increase in this right visual field advantage because of lower performance on the left visual field and a decreased redundant bilateral advantage. Secondly, this was a study by Bradshaw in 2020 and colleagues, and they replicated the study of Henderson et al., but in a bigger sample size. And again, they found this increase in right visual field advantage because of lower scores on the left visual field. However, they were not able to replicate this reduced redundant bilateral advantage. So that was a bit weird, and they concluded, there is some evidence for this interhemispheric transfer deficit theory, but it's not very clear what's going on. Now, okay, interesting studies, but the weird thing is both or none of the two included reaction times in their studies. That's because they used a task where they asked the participants to type the word they saw that was presented to the visual fields. And of course, you cannot measure reaction times then. So I thought it's probably more apparent in reaction times, these effects of the visual field advantage and also the redundant bilateral advantage, because we're talking about relay times between the two hemispheres. So it might be more sensitive and more apparent. So let's include reaction time, and that's what I did. Now, to include reaction times, as I said, I needed kind of a different task. And so that's why I used the lexical decision task, but more about that right away. So these are some of the demographics of my study. I was able to find 44 people with dyslexia, and I matched them quite perfectly, as I might say so myself, with normal controls. They had about the same ratio male-female. Age was quite matched well, and the number of formal educational years. And then, as you can clearly see, they were very, very different when it comes to non-word reading and spelling scores. I was actually quite surprised when I did this analysis, but okay, it was very, very significantly different. Important to note, they were all right-handers. I didn't include left-handers to make sure that we didn't have any funky results because of the lefties. And also, there were no other developmental disorders in these people, because I have 44, and in my abstract, I had a little bit more, but I just wanted to take those out as well to keep it as clean as possible. So that's why 44. Okay. This is my task. So I use a lexical decision task, simply asking the participant, is the string that appears on the screen, is it a word or is it a non-word? So I had 80 words and 80 non-words. They were all 5-letter words. And I repeated those in the 3 conditions: left visual field, right visual field, and bilateral visual field. It looked like this: the fixation cross in the middle. Then you had the stimulus, either on the right, as in this example, left or both the same, then a masking for the same amount of time, and then this screen again until they responded. How did they respond? If they thought it was a word, they pressed both index fingers at the same time. And if they thought it was a non-word, both middle fingers at the same time, just to exclude left-right responses. Okay. So for the results, first I'm going to describe the accuracy scores and then go to the reaction time, the most new part of this study. And for accuracy scores, please forgive me, but I used error rate instead of accuracy, because that way my figures look the same when I'm talking about reaction time. So the higher the score, the worse they perform. And if you look at the screen, you can see on the left side, it's the controls, and on the right side, dyslexia, and then left visual field, right visual field, bilateral. Okay. First, let's go to the right visual field advantage. So we need these parts of the graphs. You can see that they are performing, the error rates are higher in the left visual field. So this means more errors when it's presented to the left visual field compared to the right. So this is exactly what we expected. And it was the same in the people with dyslexia. So more errors in the left visual field compared to the right. If we subtract the two from each other, a negative score means that they have a right visual field advantage. You can see in both groups, it is there. However, there is no significant group difference. Then over to the bilateral redundancy, the redundant bilateral advantage. So it's the right side of the graphs. You can see again, better score on the bilateral presentation compared to the right visual field. And it looks similar in the group with dyslexia. So indeed, if we have the 0 line, above 0 means that there is an advantage. Both groups have this advantage. And again, there is no significant group difference. So this was a bit surprising because that was the accuracy dependent measure. And I was kind of expecting that it would be the same as in the previous studies by Henderson and by Bradshaw and colleagues. So now I want to go to the reaction times, and I can be quite brief. It actually looks almost the same as the error rates. However, it's not more apparent, but less apparent. So to quickly go over it, for the right visual field advantage, we can see that they are a little bit faster than compared to the left visual field in both groups. It is barely significant, and it's not significantly different between both groups. And then if we go to the bilateral redundancy advantage, we can see again quick, faster responses on the bilaterals in both groups and not significantly different from each other. Okay, discussion. So the main take-home message is my hypotheses were not confirmed. I didn't find an increased right visual field advantage. They didn't perform worse on the left visual field compared. I mean, the difference was not increased between left and right visual field. There was no decreased redundant bilateral advantage. In the error rate, it even seemed to go the other way around. And I didn't see more apparent patterns in reaction times compared to accuracy scores. So what the hell is going on? I don't really know. I've just been thinking about this. Of course, one of the most obvious differences between the studies of me and Henderson and Bradshaw is the fact that I used a lexical decision task instead of typing a word. It's a bit more of an executive task, and you can often see in studies that it's a little bit less clearly lateralized. However, the task does yield a right visual field advantage. So I feel like I am probing this left hemisphere function, but as I said, it also seems to be a bit less robust compared to previous research. So yeah, I would like to say thank you also to Guy for having me in his lab for so many years and helping me now with this new study. Robin and Emma with helping me with this study, both thinking about it and helping me scan and test and whatever, listening to me when I need to. And if you have any questions or ideas of what's going on, I would love to hear them. Thank you.
Has an idea.
Hello, Helena. Thank you very much for that. I might tell you that every experiment I've ever carried out with dyslexics doesn't really work, except for one that I published in Neuropsychologia so many years ago that I can't honestly remember, but it was a tactile transfer experiment. Seems to me to be something ever so slightly troubling about asking dyslexic people to do things with words and non-words, and all sorts of different explanations that one can have. So if you really get stuck, try a tactile task.
Yes, thank you. Actually, I didn't present it today, but one of the suggestions in the Bradshaw discussion of their paper was use a non-verbal task, because if it's all about interhemispheric transfer, you will also see this in other cognitive functions that have nothing to do with language. So I also did almost exactly the same setup, but with a symmetry detection task, where they were just seeing figures and saying whether they were symmetrical or not. but I got almost the same results, except that the lateralization is even a little bit weaker with the symmetry detection task than the lexical decision. So, yeah.
Was Dorothy Bishop one of the authors on the Bradshaw paper?
I think so, yes.
And the Henderson paper, was that one with Andy Ellis? Can you remember?
I don't know.
Okay, thanks very much.
Thank you.
Thank you, Alan. There is a question in the chat here, whether you controlled for the degree of handedness within the right-handers.
I did not. I still need to look at it. I got the EHI scores, but they seem to be quite consistent right-handers actually in the group of dyslexia. But this is definitely something that I can take into account. Yes, I just need to do it.
I have not a comment, not a question, but rather a comment about your visual half field task, because given that you couldn't support your hypothesis, you came up with the explanation that maybe the visual half field task isn't robust enough, or I don't think you need to say that, because obviously your visual half field task worked very well. So you showed a very solid right visual field advantage, as you would expect. So I think there's nothing wrong with your paradigm. But interestingly, I think for whatever reason, so when I've used the visual half field task in a similar way like you did, or in other ways, it was always the accuracy that was more sensitive and more robust than the response times. Whereas for other stimuli, spatial stimuli, for example, it was quite often the other way around. So,
it's not just me.
It's not just you.
Okay, thank you. Yeah, I was actually, because this is what I also wanted to show, that even though we have a right visual field advantage, you can see that, I mean, here there are 5 people in the control group that show the left visual field advantage, but here in the people with dyslexia, that's also why I said, like in the Bradshaw and in the Henderson paper, they had like a handful of those, and I have a lot more. So that's also why I'm a bit feeling like, yeah, a bit uncertain. But yeah.
Hi. I was just wondering, I don't know this literature at all, but in the executive function literature that is often used a speed accuracy trade-off measure, because people often slow down to get more accurate. And I was wondering if you created a score like that, whether that would.
I haven't, but that's actually a really good idea. Yeah, thank you. For the accuracy score, for the reaction times, I also only use the correct trials, but that's a really good idea to look at that. Thanks.
Hi, aren't the variances different in those two groups?
I don't know.
Well, it might be worth looking at. There looks a lot more variability in the dyslexics than the controls. We both said the same thing. That's why I'm asking.
Yeah, thank you.
Good. No further questions? Then thank you very much.
Okay, thank you.